Okay, so for today we're going to be doing our first mission to and from Moho, which is the closest planet to the Sun in Kerbal Space Program, and it's surprisingly one of the hardest to get to, in my opinion. I say hardest to get to not really because it's particularly difficult to land on, but just because of its relative speed to Kerbin, given the fact that it's the closest to the Sun. That of course means that by lowering our solar periapsis, we'll be coming in to Moho at a really fast speed, and as such, we're going to need to, in order to get ourselves slowed down around Moho, we'll need to do a really expensive burn. Given the fact that this is my first time going to Moho, it goes without saying pretty much that this isn't my first time recording this, this is about my third or fourth attempt, and I finally managed to design a rocket that allows me to get the Delta V I need in order to get captured and return from Moho, but also to take off from Kerbin. All that out of the way though, what you see me building here is actually the lander, and you can see I actually put the Apollo-style command pod upside down right now because I figured out that the reason that Kerbal Engineer Redux was messing up when telling me the Delta V calculations is it was assuming that I would be controlling from the lander whenever I do these Apollo-style missions, so I've solved that by just placing the Apollo-style command pod upside down first, and then attaching the docking port, and then the lander to it, and that seemed to fix my problem. Another thing I should mention is that since this was actually my first time landing on Moho, I kind of expected it to be a lot bigger than it was, and so I packed far more Delta V on this than I needed to, but that did allow me to be a lot more liberal with my usage of fuel during my descent, because generally just the only times you really have to take risks is when you're trying to really budget out fuel. So this allowed me to ensure that I had a successful trip. That said, while I did put a lot more Delta V in the lander than I needed to, I think I got it pretty much just about right with the mothership here. It doesn't display it correctly on the Kerbal Engineer Redux, but we do have about 7,500 meters per second of Delta V, which is quite a bit, and you'd think that might be a bit overkill, but I end up returning to Kerbin with only 400 meters per second of Delta V left in the craft, because just circularizing around Moho cost me over 3,000 meters per second of Delta V. So you can see, as per usual, for my mothership, I've gone with the choice of nuclear engines for our engines for that stage, and the issue with nuclear engines, and the only reason that I don't use them for every stage, is because they have such a terrible thrust-to-weight ratio, and while this doesn't really matter as much in a vacuum, it still does matter because of that lower thrust-to-weight ratio, it takes us longer to get going and then stop, so that means that my circularization burn to get around Moho took 12 minutes. Thank god I have time warp, but it took 12 minutes because the thrust-to-weight ratio is so low, so I have to start burning 6 minutes before my periapsis and then 6 minutes after my periapsis, and as the Oberth effect states, the closer you are to your periapsis, the more efficient that your prograde and retrograde burns are, which is why you always see me try and do prograde and retrograde burns at periapsis of places. But my point is that having to burn for really long on either side of my periapsis is pretty fuel inefficient, and that's generally why sometimes you'll see people do 2 burns at periapsis while they just get captured with the first burn, and then get more circularized with the second burn, because they can spend a longer amount of time burning at periapsis. Anyways, I've kind of managed to ramble my way through the rest of the construction of the rocket, so we will go ahead and get ready for the launch. So obviously you'll notice that the rocket doesn't look exactly the same as it did whenever we left the VAB, and that's because this launch is my third or fourth launch, and the issue that I kept having was that I didn't have enough thrust-to-weight ratio with my stage after the boosters were gone. So what I ended up doing to solve that was putting more fuel on, or I got one extra booster and putting more fuel with more powerful engines on them just to help us get off the ground here. And then now that we've got this bigger stage here, the gravity is less strong since we're higher up in the atmosphere and we don't have to worry as much about thrust-to-weight ratio. But looking on screen, you can see we've just separated the fairings to reveal the rest of the rocket, and we have completed our burn on the lower stage and begun burning with the interplanetary stage. And as per usual, I've been using the Rhino engine for this for our circularization, and then since I ended up overpacking a little bit of fuel, we're going to use this ascension stage to help us do our burn to Moho. Getting an encounter with Moho was exceptionally difficult compared to some of the other planets, like particularly Drez it reminds me of because it's of similar size and it pretty much looks the same to be honest. But the thing that makes getting to Moho hard is, like I said at the beginning of the video, it's the relative speed compared to Kerbin. And so you can actually see me here. I'm using MechJeb, which is a mod I got, which basically sort of automates that burn time for me. And I realized after I launched that I kind of forgot to wait for a Moho transfer window. So thankfully, MechJeb kind of reminded me of that. And so Bill, Bob, and Jeb there kind of had to sit and wait in low Kerbin orbit for like half a year. But anyways, we were able to get away with a relatively cheap 1500 meter per second ejection burn. Another thing I should mention is that we did wait until Kerbin was at Moho's, or at least near Moho's descending node, which basically is the point at which, or actually I guess I should mention first that Moho is on a slight orbital tilt you can see there, so I have to get my y-axis adjusted a little bit too, but by waiting to leave Kerbin until our descending node, we're able to do it all in one burn and avoid a really expensive orbital inclination change. And I mean, it's like really expensive. Like I think the orbital inclination change just for like the 10-degree tilt that Moho is on, that little thing we did there saved us like probably like 800 meters per second of delta V. Another thing that makes getting to Moho particularly difficult is its size. It's pretty small, which means that its gravity well is equally small, and it's pretty. I think the size is pretty comparable to Drez, but that just means that we have to have first a really slow orbit when we get there. The orbital velocity at Moho for like 100 kilometers is still pretty slow. It's like 500 something meters per second. But given Moho's first orbital inclination, second small size, and third extreme like change in relative velocity from Kerbin, that makes it really hard to get like an intercept with. So you can see here I'm trying to do my whole orbital or my whole circularization burn in one burn, and that amounts to like over 3,000 meters per second of delta V, which is over half the fuel I packed for this stage. But fortunately, we do have a little more delta V than it appears because we will be detaching our lander, though by the time it gets back, it will be mostly dry mass. But that number that you see on the left, the blue and white number, which gives me the amount of delta V we have, that says that it's a bit lower than it actually is because, like I said, we're going to be leaving without the lander. But we are now circularized or captured around Moho. I'm going to do a little second circularization burn at my, I think it was apoapsis to slow down. And I just want to make sure our orbit is really circular. But we're going to go ahead and have Jeb hop in the lander, and we have gone ahead and detached. And we will just point retrograde and begin burning. And Mo is pretty flat, so we don't have to worry about like mountains that would tip over the lander. So we can go ahead and begin our descent. And you can see I've got surplus of 3,500 meters per second of delta V there. In reality, if you're particularly efficient, it probably only takes around 1,000 at most. But like I said, I've never landed on Moho before, so this is kind of a learning experience for me. And so we are able to expend what would otherwise be pretty ridiculous amounts of fuel in our landing. Seriously, like we spend probably upwards of like half our fuel just on the landing here, but that does mean that, you know, we're able to be safe with it and I can control it, or I can have really fine control over our descent, and we touch down here at pretty much perfect speed. So, as per usual, we will go ahead and have Jeb hop out of his lander and run over and go ahead and plant our flag. You can see here that as I keep doing, I keep accidentally planting the flag backwards relative to the camera, but it's not a big deal, so we'll just go ahead and have Jebediah hop back in the lander, and we're going to go ahead and try and immediately ascend to orbit without waiting for the mothership to come back around, just because we have so much fuel to mess around with. So with our roughly 1,500 meters per second of fuel, we're just going to go ahead and get into a low Moho orbit and get circularized before we try and make any burns, because normally if you were trying to be really efficient, what you do is you just wait until the mothership was passing overhead, and then you would just speed up to meet it and dock with it immediately without ever actually getting like properly in orbit. But the same way we would get into orbit around Kerbin, we will just go ahead and burn almost 90 degrees immediately once we take off and get into a roughly 100-kilometer orbit, and go ahead and put a maneuver node at our apoapsis and get circularized. So now what you can see me doing is I'm just going to, or basically the first step of docking with the mothership is to get your inclinations nearly the same, if not exactly the same, and so that's what I did here. Now that that's done, we need to go ahead and either get in a higher orbit or lower orbit relative to the mothership, and that will allow for one of the ships to catch up to the other, because as you know, a higher orbit means a slower orbital speed, and so while they just rotate like seemingly infinitely, they will go ahead and just one of them will catch up to the other, whichever is closest to the surface. And I'm again just going to take some liberties because of our extra fuel. So what I did here was I basically set my nav ball to be relative to the target, and I burned retrograde relative to the target, which means that basically I am moving like 0 meters per second relative to the target. So then what I do is I point directly towards the target, burn right at it, and then rinse and repeat until I get a close enough approach that I can actually see it. And then basically I do a kind of docking that I first saw Matt Lown do on YouTube, where he takes control of one of the ships and points it at the other's docking port, and then does the same thing with the other ship, so they both try and like automatically nose towards each other because the docking ports are on the nose of the ship. So same as with most other, if not all other, docking procedures, I'm just going to, again, kill off all my speed relative to the ship, and then try and be going around less than half a meter per second relative to the target when I'm trying to actually connect the docking ports. But for right now, I'm still trying to get our relative speed pointed towards 0, because normally I can just press a button to allow me to point retrograde or prograde, but when you're going at speeds of less than half a meter per second, it doesn't give you that option, so I kind of had to do it manually. But you can see we've managed to expend most, if not all, of our fuel in the lander stage, so we got here pretty much perfectly. I was able to waste as much fuel as possible doing our descent and docking, but we will just fold up the antennas and solar panels so they don't get damaged, and there we go, we've successfully docked. Now that we've docked, we can go ahead and transfer Jeb out of the lander thing into the main cockpit. And so now we'll begin probably the most stressful part I had of this mission, and I realized that I thought I would save a lot more Delta V than I did with removal of the lander, but I did not, and we ended up with about 2,600 meters per second of Delta V left, and so I began going ahead to plot my course to Kerbin and realized that I didn't have enough fuel and that we wouldn't be able to get back home. So I used MechJeb a little bit, and I messed around with some of the settings to figure out how I could possibly get a more efficient burn there. And eventually, I managed to find a spot in the solar system that was like 3 Moho years ahead of where we needed to be. So I just went with that, and we were able to barely scrape by. And I think we end up, after our adjustments that we need to do during the actual like correction burns, I think we ended up with something like 400 to 600 meters per second of delta V, which is shaving it pretty close. Looking back, there probably were some things I could have done to shave off some delta V requirements, like perhaps if you remember at the sort of near the beginning of the episode, I talked about the Oberth effect and doing multiple burns at periapsis or apoapsis to be more efficient. So I could have split the ejection burn into 2 burns, but MechJeb had figured that I'd be fine with just that, so I went ahead and did that. So here we are arriving at Kerbin. So once I've verified that we are gonna actually like make it to Kerbin, I go ahead and separate the bottom stage, and with the heat shield, we go ahead and start our descent. And you'll notice, for some reason, it looks like there's RCS coming off all the sides of the command pod. I'm not really sure why. The RCS isn't actually on, but it did that for like most of the mission, including while we were docking. But all of that done, here we are, finally safely splashed down. This mission was definitely a tough one, but it'll probably be nothing compared to a Jewel mission I plan to do soon, which I feel like I've been saying for the past like 5 episodes. But anyways, that's how you get to Moho and back, and I think that's about it. See ya.